So we're going to go ahead and do exercise 33 through 40. So there are exactly 6 subsets of C. So there's a way of counting this, and the way it works is the number of subsets of a set with n elements is 2 to the n, and the number of proper subsets is 2 to the n minus 1. So that's on page 53. So if we look at 33, there are exactly 6 subsets of C. So we have C, which has n, number of elements is 3. So therefore, the what do we use for the symbol here? Number of subsets. I don't know what the number of subsets. Number of subsets is equal to 2 to the n. So in this case, the number of subsets is 2 to the 3rd power, which is 8. And since 8 does not equal 3, or 8 does not equal 6, 6 does not equal 8, then the statement is false. Okay, 34. There are exactly 31 subsets of B. How many do we have in 5? We have 5. So n is equal to 5. So the number of subsets is 2 to the 5th power, which is 2 times 2 times 2 times 2 times 2, which is 32. So there are 32 subsets, and there are 31. So that's the number of subsets. If you subtract 1, you get the number of proper subsets. So the question is, there are exactly 31 subsets is false, because there are actually 32 subsets. It would be a true statement if it said there are exactly 31 proper subsets. Okay, 35. There are exactly 3 proper subsets of A. How many terms in A? We have 2. So we have 2 to the 2 power minus 1, which is 4, minus 1, which is 3, and therefore the statement is true, because that's what they say. 36. There are exactly 4 subsets of D. How many elements do we have in D? We have 2. So the number of subsets is 2 squared, which is 4, and therefore that statement is true. 37 says there is exactly 1 subset of the null set. And the null set has how many entries? Well, it has 0. So you get 2 to the 0 power, which is 1. Therefore, that statement is true. It's 1 subset. And 38 says there are exactly 128 proper subsets of U. How many elements do we have? 1, 2, 3, 4, 5, 6, 7. So n is equal to 7. The number of subsets is 2 to the 7th, which is 128. But the problem says exactly 128 proper subsets. There are actually 127 proper subsets and 128 subsets. So that statement in the book is false. Okay, and then the last 2 are to do with the Venn diagram. The Venn diagram below correctly represents the relationship among sets A, D, and U. So U is the universal set. Okay, that's the square. What it says, based on the Venn diagram, it says that A is a subset of U, because the blue circle is inside of the black circle. And also that D is a subset, I guess we'll call it that kind of right now, is of A. So is this true? Yes, A is a subset of U, because A is here and E is there. But if you look at D, D has only 1 term that's common. So this part, this is true. This is false. And therefore the statement based on the Venn diagram is false, or the diagram is false. Now the second case, you have that B is a subset of U, which is true, because we have A, B, E, F, G, A, B, E, F, G, so that's true. Now, because the red circle is within the blue circle, so C is a subset of B. Let's look at that. C is a subset of B. Well, we have B, F, and G, so that's true. So since both of those are true, then the whole thing is true. Now B is also, or C is also a subset of U, which is also true.